All right, let's keep going. So, number three. Number three, I really should have done it on the last one, but what is the limiting reagent for the reaction in number two? Well, we said that the 15.00 grams of CuCl2 was going to run out before the 20 grams that are here, right? So we said this was going to be gone. It was barely. But the answer is therefore the CuCl2. Number four. Number four says, okay, so if we had a limiting reagent, how much of this 20 grams is left over? So what ends up happening here is, here's how you do it. Again, you always start with the limiting reagent. So 15.00 grams of CuCl2. Always start with a thing that runs out. When this is gone, everything else stops. You turn it into moles. So, in 1 mole of CuCl2, there are how many grams of CuCl2? Well, you could look back in the previous problem, right? Number 2, and figure it out, and that number is 134.45, right? So you see how important it is that you calculate those molar masses right. Then, from there, what we're going to do, okay, is now, most important step, mole ratio. Now in this one, what we want to compare is moles of CuCl2. Why? So we can cancel the CuCl2. And what do we want to know? Well, it says what thing is the non-limiting reagent, or the excess. That's the NaNO3. I wrote it twice. So what we want to know here is the NaNO3. Right? We want to know how much of this. So again, on the top of the mole ratio always is what you're looking for. We don't know how many of that 20 grams is left over. So the numbers that belong here come from the balanced chemical equation. There's a 1 right there, so a 1 goes right there. There's a 2, so a 2 goes right there. Well, that's moles, and we want to know how many grams are left over, right? So we got to go one more step. And in 1 mole of NaNO3, there are how many grams of NaNO3? And again, we can go back in our previous problem and look for that information. And that number is 85. Moles cancels moles, moles cancels moles, grams cancel grams, leaving us grams of NaNO3. Now, here's where this gets a little tricky. You do the math across, right? And I get 18.97. Why? 4 sig figs, 4 sig figs. So 18.97 grams of NaNO3. Now here's where this is hard. This is how much of this was used up when 15 grams was gone. So that's what was used. But you're told in the problem that you have how many grams of it? 20, right? So what we do is we take 20.00, which is what you started with. We're going to use 18.97. So we subtract 18.97. 20.00 minus 18.97 is 1.03 grams of NaNO3 left over. Can't forget this step. It is a huge part. Okay? Okay, last problem. Number 5. Number 5 says this. It's the first time I'm introducing this idea of a percent yield. And I'm going to leave the equation up here because I'm feeling I'm going to need it. So, number 5 says this. If 11.3 grams are formed, so 11.3 grams are actually made. Okay, and that is of sodium chloride, so that's NaCl. It says, what is this, are formed in the reaction, describe what is the percent yield. Well, from problem number 2, we said We should have made 13.04 grams of NaCl. And again, that's coming from problem number 2. Should have been made. Okay? Well, we have something called the percent yield. And what we do on the percent yield is we take what we actually get, actual, over theoretical. Theoretical means if it was perfect, you would have made 13.04 grams. Now, why didn't you make 13.04 grams? There's a number of reasons. There could be laboratory errors. You could have rounded wrong. You could have not gotten every bit of substance to transfer from one beaker to another. Your scales could have been off. I mean, there's a number of reasons why. So what we do for percent yield is we take the actual amount, what we actually get when we did the lab. Okay? That'll always be told to you, by the way. We divide it by the theoretical. Again, what is theoretical? It means if we had a perfect world, what would you have? So your actual is that one. Your theoretical is what should have been made. And then because it's a percentage, we multiply by 100. So in this case, what we do is we take 11.3 and we divide by 13.04 times 100. 11.3 being the actual, 13.04 being the perfect yield. When we do this, we get a calculation which is 86.66. Now you might say to yourself, Mr. Green, what do I do with regards to student figures? I'm going to try to make this as easy as possible. Anytime it's a percent in this whole class, round to the hundredths place. Let me say that again. Percentages round to the hundredths place. So when you do this, you get 86.66%. And that's the answer to number 5. And guys, numbers 1 through 5 is the hardest I can make stoichiometry.